In the last part of this section, we are going to look at inverse hyperbolic functions. So if you go back and look at the hyperbolic functions, if any of those graphs are not one-to-one, all we do is limit their domain so we can talk about their inverse functions. So remember, those hyperbolic functions were defined in terms of exponentials. These inverse hyperbolic functions are defined in terms of logs, which are the inverse of exponentials. So we have the definitions here given along with their domain. The next slide you can see their graphs, right? And those are all coming from kind of the relationship of the inverse original hyperbolic function. We're going to focus on the calculus involved with those, which would be going back to the derivatives and integrals. So that is where our formulas here on this slide are coming from. So I can see that I'm looking at the derivatives for each of those inverse hyperbolic functions, and then these integrals. Notice that these involve squared pieces in the denominator, and I'm getting back to natural logs. So that's kind of getting back to the definition of those inverse hyperbolic functions. All right, for our first example here, we want to find the derivative. In this case, I'm taking the derivative of the hyperbolic tangent inverse of x over 2. So we can kind of glance back at that last slide. Here is my formula for the derivative of the inverse hyperbolic tangent of u. That's telling me that is u prime over 1 minus u squared. So in our case, if I identify my u, that is what is inside my hyperbolic tangent inverse, and that is x over 2. So that means that u prime is the derivative, which would just be 1/2. So then as I'm finding the derivative here, remember we said that this formula was u prime over 1 minus u squared. So in our case, u is x over 2, u prime is 1/2. So I have 1/2 over 1 minus x over 2 quantity squared. So if we simplified this a little bit, I could think of this as 1/2 over 1 minus x squared over 4, squaring both of those pieces. And then we could find a common denominator in the denominator of this fraction, so that I could think of my 1 as 4 over 4. So I could write that as 4 minus x squared over 4. And then we can, instead of dividing, think about multiplying by the reciprocal. So I have 1/2 really times 4 over 4 minus x squared. My 4 and my 2 could reduce to leave me with 2. So really I have 2 over 4 minus x squared for my derivative. All right, so another example here, finding the derivative. Here I'm taking the hyperbolic secant inverse of cosine of 2x. And as I'm looking at this, kind of going back to my formula here for the derivative of my hyperbolic secant inverse function. So we can see that that formula is given to us right here. So I'm going to know that's going to be negative u prime over u times the square root of 1 minus u squared. So if we go back to our formula here, our equation, our u, in this case what is inside that hyperbolic secant inverse, is equal to cosine of 2x. So if I find u prime, I'm using the chain rule. The derivative of cosine is a negative sine. So I have negative sine of 2x. That inside doesn't change. But then I multiply by the derivative of the inside, and the derivative of 2x is 2. So I'm going to write this as negative 2 times the sine of 2x. All right. So then the formula we just said we were using was that negative u prime over u times the square root of 1 minus u squared. So giving that starting point here. So as I look at negative u prime, I have the opposite of our u prime that we just found, which was negative 2 sine of 2x, all over u, which was cosine of 2x, times the square root of 1 minus u squared, so 1 minus the cosine squared of 2x. And then as we're looking at this or simplifying this, notice that really in the top, these two negatives, a negative times a negative would just give me a positive 2 sine of 2x. And then in the denominator, as I'm looking at this, I have the cosine of 2x, and then 1 minus the cosine squared of 2x would be equal to really the same thing as sine squared of 2x, using that Pythagorean identity. So as we're continuing to simplify here, I have 2 sine of 2x in the top. The square root of sine squared of 2x would just be sine of 2x. So I can simplify that squared underneath my square root. And then we see we have a sine of 2x in both the top and the bottom, so those could cancel each other out. So then I'm left with 2 over cosine of 2x. But if I have 1 over cosine, remember that's really just the same thing as secant. So I really just have 2 times the secant of 2x when I simplify my answer here.